Hello, everyone. So, the other day we spoke about the three different states of matter, and I hope that we can just revise those states of matter first. Yeah, so we have the solid, we have the liquid, we have the gases. This is nothing new to you. The only thing that's new to you is the introduction of the particle model. And in today's session, we will look into how the different states of matter will interchange with one another, and we are going to use the model. Yeah, and this is in a picture form, unfortunately. But when I get back into class later, yeah, we will definitely do a little bit of a hands-on activity to make sure you fully understood my concept. All right. Now, you will be hearing this live, but at the same time, once the recording is done, and if you wish to listen to it again, by all means go ahead because it's meant for you to be, used on this sort of basis. Okay. Now, the topic that we're going to talk about today here is the models of expansion and contraction. Let's just revise on the three different types of states. Yeah, we have the states of solid, liquid, and also gases. Nothing new over here. The only thing that's new for some of you would be how solid would change into gas immediately, and that is through a process called sublimation. And in the opposing direction, gas changes to solid in what we call deposition. So it does make sense because gases do deposit into a solid. The others are very common. Yeah, you have solid going to liquid, and that will be in the melting process. Liquid to gas is vaporization, which means it's a change to vapor. Now, vaporization, you have two processes here, right? You have boiling and you have evaporation. Both of them are the same thing. Nothing new for vaporization. You would have heard it in the previous topic on separating mixtures, and that will be part of your distillation technique. All right. So if you can't remember distillation, do go back and reread your textbook and reread my notes as well, so to make sure that you're on track with what you're doing. Okay. And of course, the reverse, gas to liquid, condensation, and liquid to solid would be freezing. All right. Nothing new for you. But the only thing that you also need to know besides sublimation deposition are gaining in energy and losing in energy. You've got to make sure that if a state of matter changes from solid to liquid to a gas, it will be a gain of energy, and we will understand why it's a gain of energy. Then from gas to liquid to solid is a loss in energy. All right. Now, having said that, I have done this pictorial for you here. Okay, so whoops, I did not actually color this in blue, and I'll tell you why I had that coloring. All right, so we need to know the idea of expansion and contraction. Okay, so you know that a certain state of matter interchanges with one another is because of heat energy. That's number one. Number two, when heat is heated up, oh sorry, not heated up, when matter has been heated up, let's just have a look at the particle arrangements here. Now you notice that this here, all the particles are close to one another, yeah? All of them are close to one another, that is leaving very little space in between. So if I'm going to gain energy, and I know that my particles are vibrating at the same spot, what do you think is going to happen if it receives energy? Yep, if you have guessed it correct, it will definitely absorb that energy. It will gain the energy. And as soon as the particle gains the energy, it vibrates a little bit more. Yeah. And the particles will move further apart. That's the fact. Oops, sorry. They will move further apart. And you notice that the distance will increase between particles. So once energy has been gained, let's look over here. Do you notice this particle, and there's a much bigger space and less contact as compared to the diagram over here. So what we are trying to say here is, how does expansion occur? Expansion occurs is because the particles, in terms of their distance, has increased. So when the particles increase in distance, we are also trying to say volume is also gained in the process. Volume gain as in it becomes bigger in terms of the spatial arrangement, and it has expanded. Okay, if you get what I'm saying. Volume of matter has actually expanded in this case. So you can see there's a little bit more space. And that's why I had all the keywords in red, yeah, to notify you that there's heat energy being provided. That means you're getting more and more heat. Now, the opposite will hold true if they lose energy from a gas, liquid to solid phase. We're going backwards this time. So if matter has been cooled down, you notice that energy will also be lost. So when there's less energy, there'll be less vibration. And therefore, there will be less vibration. Particles will move closer, the distance will decrease, and you notice that your volume will also decrease. This is known as contraction. Contraction is the opposite of expansion. Okay, so you may not be able to see what is going on here properly. So the next slide will be a little bit better, because it will just give you a summary of expansion and contraction. All right, so you need heat energy to expand, right? We are not talking about expanding the size of the particles. We are talking about expanding the distance between the particles. It's the distance that will tell you about the volume, okay? So here is nothing new. You just basically need to understand when you receive energy, you will expand. You will expand is because your particles vibrate. And when it vibrates, it overcomes a certain forces of attraction, which we will talk about in the later lesson. Yeah. And of course, the opposite holds true when they contract. Why do I emphasize on this? Is because if you cannot remember one, if you just remember the opposite of the process, it is just a play of English where you just replace and substitute the words of more to less, expansion to contraction, if you get what I mean. All right, but this is in solid and liquid particles because they're quite close to each other. So we are talking basically about solids and liquids. Next one is what we call the gas particles. And if you know gas particles, they are actually very far apart, but they have a little bit of a special property here. We can just imagine them in a balloon form. Yeah. So when the gas particles were to receive energy, and of course they are really further apart, what will happen here is they will knock against the walls of the container. Once they knock against the walls of the container, they will gain more energy. And they gain more energy, and therefore they will expand. But remember, for the gases here, there will be a limit and there will be a point of breaking. So when it breaks, it will burst basically. And of course, your gas particles are released. Now, the reason why balloons burst is because all the gas particles here have already received energy. They receive energy, they collide with each other, they knock against each other, and besides that, they knock against the walls. All right. So when they knock against the walls, they keep trying to push the balloon out, expand and expand and expand. Okay. Until there is a point of no return where there is too much and it has surpassed that limit, it will break. Okay. Now, I will also attach you one link which I think you will find very interesting and it'll be a little bit interactive for you to look through. Okay. So this would be what I call the PHET interactive model of the states of matter. I wouldn't worry so much about phase changes. I'll concentrate more on the states first. All right. So let's go. Now, do you see that at 14K, that means 14 Kelvin, yeah, we will have all the solid particles of a particular substance called neon, which is in group 8, and you will learn about that in the atoms and molecules. Now you can change it to argon, to oxygen, or even let's go to water since we're talking about it. Yeah. So you can see these are all your water particles gathered together, and notice there is what I call an open structure. There's quite a big volume, and therefore you notice that if you think back, ice is actually less dense than water. It's because of all these spatial arrangement here. All right. So let's just say, for example, if I want my solid to be in a liquid, so now I have gained, some energy. So if I change it into liquid, notice that it is randomly moving, but it is still, besides each other. They are really side by side. And notice that all of these are moving in a random order. What about if I want to increase and give more energy to it? So I will change into the gas state. And this is what happens. You will see all the particles here moving around and about. You can also play around by increasing the temperature. All right. And if you increase the temperature, notice that your particles are getting a little bit more excited. They are gaining more energy. They are moving randomly and they're knocking and colliding each other. Or you might perhaps want to say, all right, I want to cool it down a little bit. Right, so when it cools down, you will notice that there's some particles are actually slowing down, all right, as compared to just now. So if you were to just scroll down way beyond, like coming to room temperature, you notice that there is a change. Okay, so really, I hope that you will take this lesson to enjoy with this interactive module session that I have here, because this is a chance you have online, right? And when we come back, we will talk more about the theory part and make sure that you enhance it. Okay? Thank you for listening. Let's see. Let me see whether this is okay. Let me go back to this. I'm switching this one off. Okay.